Lesson 5.5, two variable linear inequalities. Okay, so we've already graphed an inequality in one variable on a number line. A linear inequality is similar to a linear equation so that it has two variables, but instead of having infinite solutions along a single line, like we had a single variable inequality, a linear inequality has infinite solutions in a half plane. Well, what's a half plane? Okay, so the coordinate plane is a plane. It is a whole plane, and it is infinite in in all directions. A half plane is if you graph an equation of a line on a coordinate plane, you get a half plane. You also get another half plane. So when we graph an equation of a line, we get two half planes. Graphing a linear inequality, the first step is to graph the line of the relative equation. So if we take the inequality symbol out and we put an equal sign in, that's how we get a relative equation. So if we're given the inequality 3x plus 4y is less than 16, the relative equation is 3x plus 4y is equal to 16. This is the line where we graph. The next step is to determine the line to graph. Inequalities are graphed with a solid line like this or a dashed line like this. If you have a less than or a greater than only, you graph with a dashed line. If you have a less than or equal to or a greater than or equal to, then you graph with a solid line. So let's talk about, now that we've talked about the qualifications of linear inequalities, now we'll actually go and graph some. Okay, now that we've talked about the linear inequalities, we need to actually graph some linear inequalities. So the first thing we need to do is have an inequality to graph. So I'm going to start with one that's already in the y equals mx plus b format, just to make it simpler to start with. We'll make our coordinate plane. And what line we're actually going to be graphing is the relative equation. And the relative equation of y is greater than or equal to negative 2x minus 2 is y is equal to negative 2x minus 2. We're going to graph this line. Okay, so we'll start with our y-intercept, which is at negative 2. And then our slope is negative 2, so since our slope is negative 2, we're going to go down 2 and then over 1. So down 2 and over 1. And then we'll connect these with a line. Now, if you remember, we said that if you had a greater than or equal to or a less than or equal to, you would use a solid line. So for this graph, we're going to use a solid line. And this will cut our coordinate plane into two half planes. And one of these half planes will need to be shaded to indicate which side of the line are all of the values where y is greater than negative 2x minus 2. So at this point, what we need to do is we need to pick a point that is not on the line. Whenever possible, I like to pick the point 0, 0. If 0, 0 is not on the line, it's an acceptable point to pick. If 0, 0 is on the line, you pick any other coordinate anywhere that's not on the line. Then we plug in that point 0, 0. So I have my equation. I'm going to plug in the point 0, 0. So 0 for x and 0 for y. And I get 0 is greater than or equal to negative 2. This is true. Since I have a true statement, I will shade the side of the coordinate plane that contains the point that I used. If I got a false statement, I would shade the opposite side. So we'll just shade this whole side of the coordinate plane, And what that does is that tells me that anything on this side of my graph would make a true statement. So let's try another example. Let's try the example y is less than negative 1/3 x plus 1. Okay, so I'm going to make my coordinate plane. I graph the line y is equal to negative 1/3 x plus 1. So I start with my y-intercept at 1, and since my slope is negative 1/3, I go down 1 and over 3. So down 1 over 3, which brings me here. Now this time I have a less than, and since I have a less than, what I need to do is graph a dotted line or dashed line. So instead of just drawing a straight line across, I'll dash my line as I go. Like that. That indicates that it's a less than or greater than with no equal to. Then I'll pick a point. This time I'm not going to pick the point 0, 0. I'm going to pick this point here, 2, 2. And the reason I'm doing that is because I wanted a point that would be false. So when I plug in the point 2, 2, I have y is less than negative 1/3 x plus 1. So I have 2 is less than negative 1/3 times 2 plus 1. 2 is less than negative 2/3 plus 1. Now 1 is 3/3. So negative 2/3 plus 3/3 gives me 1/3. And I get that 2 is less than 1/3. This is false. And since I got a false statement, I need to shade the other side of the line. So I'm going to shade this side of the line over here where my point is not. Okay, and that'll always be your indicator. If you pick a point that's not on the line, every point on the line will be true-ish. If there was an equal there, it would be true, or if a less than or greater than or equal, it will be true. If you're on the line and you have a less than or greater than, it'll be false, but that doesn't indicate to you which side to shade. So you always need to pick the point not on the line. Then if you get a true statement, you shade the side with the point, and if you get a false statement, you shade the opposite side. So let's try some that are not in y equals mx plus b format. We can graph 2x minus 5y is less than or equal to 10. So I'm going to make my coordinate plane. And I could graph this in two ways. I could graph this particular one using intercepts, or I can convert to y equals mx plus b. I'm going to go ahead and convert to y equals mx plus b. So I'm going to pick this 2x up and I'm going to move it to the other side, and that will make it negative 2x plus 10. And then I'm going to divide everything by negative 5, and I'm going to get that y is less than or equal to 2/5 x minus 2. So I'm going to start at negative 2. That's my y-intercept. Then I go up 2 and over 5. So up 2 over 5. And then if you needed more points, you would continue to go up 2 and over 5. I have a less than or equal to, so I can use a solid line. So I'll graph my line. And then I'm going to pick a point to plug in. I'm going to pick 0, 0 because that's not on the line, and again 0, 0 is the easiest, and I usually pick that. So I get 0 is less than or equal to negative 2. That is a false statement, so I will shade this side of the line where that point was not. And that is the half plane that contains all of the solutions for this inequality. So every point on this side would be true. Let's try one more that's not in y equals mx plus b form. Let's do the line 8x minus 3y is greater than 12. So first I'm going to go ahead and convert this one. I get negative 3y is greater than negative 8x plus 12. I divide everything by negative 3. And I get y is greater than 8/3 x minus 4. So I'll go ahead and come over here and make my coordinate plane. Okay, I start at negative 4. That's my y-intercept, and I'm going to go up 8 and over 3. So up 8 and over 3. I have a greater than, so I have to graph this with a dashed line, not a solid line. And the difference between the dashed line and the solid line is when you have a solid line, that's because you have the greater than or equal to, less than or equal to. It indicates that the points on the line are also part of the solution. The dotted line indicates that the points on the line are not actually part of the solution. The solutions are only up to the line. That's what that's about. I'm going to pick the point 0, 0 because it's not on the line. And I get 0 is greater than negative 4, which is true. And so I will shade this side of my graph. And that is how you graph linear inequalities in two variables.